Hello everybody. So for today, we're going to talk about U substitution. And to start, the main idea of U substitution is it is actually the chain rule backwards. So assume U is a differentiable function and N is not equal to -1. And what we learn from the chain rule here is if I want to take the derivative of u to the power of n plus 1 over n plus 1, based on the chain rule, you're going to have it's u to the power of n, right? So you can apply the power rule here, and then are going to give you it's u to the power of n plus 1 minus 1. And then also n plus 1 you bring in the front over n plus 1, so they cancel out. So that leaves u to the power of n. And then multiply du dx because u is a differentiable function, right? So as we just talked about. Now, when we have a problem like this, if you have an indefinite integral u to the power of n du dx, and then eventually you're going to see that it's going to be u to the power of n plus 1 over n plus 1 plus c, right? And we know that this is called the antiderivative of u to the power of n, right? So how do we know our solution is correct? Well, very straightforward. If you take the derivative of the antiderivative, that should give you the integrand, which is u to the power of n, and we already know that from the top. Okay, so this is the I would see that as spirit of the u substitution. So now let's go through three problems for this worksheet. Question 1: let a be a non-zero constant. Evaluate integral a to the power of ax dx by setting u equals ax. Okay, so let me write here. Question 1. So we have integral e to the power of ax dx. Okay, and we move here. And okay, so again, a is non-zero. Okay, and the setting u equals ax. So set u equals ax, and when you take the derivative of u with respect to x, you're going to have it's du dx equals a. Okay, equals a. And we learned a definition of differential, right, in calculus 1. So to build a relationship between du and dx, this is what you can do, guys. You can think about it as this du and dx is both differential. So very straightforward. You can get that du equals a times dx. Okay, so this is what we have. So now you can see that we have u equals ax, right? We have du equals a times dx. We can start to do our substitution. Okay, so let me move about. So what we can do here is make the substitution here. So since ax equals u, so for here I have e to the power of u. Okay, and also I want to replace dx or substitute dx in terms of du. Look at what we have here. We have du equals a times dx, right? So do you agree dx equals du over a, right? Or 1 over a times du. So you're going to have it's 1 over a du here. Okay, right? Because if you divide by a on both sides, that's going to give you dx. So, all right. So a is a non-zero constant, and this is what we can do. We can take this 1 over a outside of this integral, so that's going to give us this e to the power of u du. And this is a very straightforward exponential integration, right? So, and we all know that this is 1 over a times e to the power of u, right? And then plus a constant c. So, our final answer should be a function involved with x instead of u, because we want to make a u substitution to help us solve the problem, but to the very end, we should substitute u back with ax. So our final answer here should be y over a times e to the power of ax plus the constant c. Okay, and if you take the derivative of our answer, and you can see that you're gonna get it's e to the power of ax. Okay, so that's our first problem for this u substitution. It's very straightforward. Okay, so now let's look at another problem here. Okay, and it's a geometric problem. Okay, so it asks us to find, okay, what is the antiderivative for fx equals secant of x. Okay, so this is the problem what we have here. Okay, so it actually gives you some hint for this problem. So let me write it out here. This is question 2. Okay, the problem is, okay, find the antiderivative for secant x. Okay, so that's our problem. Okay, and it gives us some hint. First of all, multiply the integrand by tan x plus secant x over secant x plus tan x. Okay, and noticing that this fraction here, which is 1. Okay, we multiply the integrand by a constant 1. We didn't change anything. Okay. Okay, and the second step, it said that, okay, set u equals secant x plus tan x and find the du. Okay, and then to integrate the new integral and then substitute it back. All right, so let's follow those steps and to see what happens here. Okay, so first step, okay, multiply the integrand. So let's do that. That's gonna give us secant x multiply tan x plus secant x, okay, over secant x plus tan x, right, and then dx. Okay, so far what I just did is just to multiply it. Okay, and I can distribute this secant x to the numerator, right? So that's going to give us secant x tan x, right, plus secant square x over secant x plus tan of x. Okay, so up to here, I think some of you might already notice that there are some relationship between these numerator and denominator. If you take the derivative of secant of x, that is going to give you it's a secant x tan x here. And if you take the derivative of tan x, that is going to give you its secant square of x. Okay, so you see, in other words, the derivative of the denominator gives you the numerator. Okay, so that's exactly why in the second step it says that set u equals secant x plus tan x. Okay, so let's do that. So u equals secant x plus tan x. Okay, and again, du dx, as we just talked about, which is secant x tan x, right, for this part, plus secant square of x. Okay, cool. And sorry about that. Okay, so And we know that we're going to use the idea of differentials to build a relation between du and dx. So basically, you just multiply dx to here. So what you do here is dx, okay? Super easy. So now you see that we have this u equals secant plus tan. We have du equals this thing times dx. So we can make our substitution, okay? So let's do that. And first of all, do you see that this secant x tan x plus secant square x dx, which is exactly du here, right? Okay. So, and also this secant x plus tan x, which is u here. So after you make the substitution, eventually you're going to have it's 1 over u, and then du here. Okay, du. Okay. So after here, things become very straightforward, right? Because the integral of 1 over u du, as we learned, is going to be ln absolute value of u plus constancy, right? So that's what we learned from the integration for the logarithmic, right? So in other words, so and don't forget to substitute u back. So that's going to give us the ln of absolute value of secant x plus tan x, right? And then plus constancy. Okay, so we finish the second one. Okay, finish the second part. All right. So now let's move on to